given a system of three equations, and today we're learning to solve them to find a point of intersection by substitution. Now, each equation has two variables, x and y, x and y. And whenever we solve by substitution, we have to try and substitute one of the variables with an expression that's represented with the help of the other variable. Now, how do we achieve that? We will try to isolate either the x or the y by itself and see what is represented by. So let's see if we can isolate x in either of the two equations. In equation number 1, the x has the coefficient -8. In order to isolate it, whatever expression I'll have on the right-hand side will have to be divided by -8. And I will start working with fractions, not the most desirable thing. In equation number 2, x has the coefficient 3, and the same thing. I will have to divide something by 3, and again, working with thirds, not the most desirable thing. Let's concentrate on the y variable. In equation number 1, y has the coefficient 3. Let's see if we can find a y that has the coefficient 1. And in the second equation, y has the coefficient 1. So I'm going to choose that second equation to isolate the variable y. So let's write it down here. So 3x minus y equals 6. Now, how do we isolate y? I want y on one side, everything else on the other side. So I'm going to move the 3x over. Negative y equals 6 minus 3x. Now, y is still not a positive value. It still has a negative in front of it. So I'm going to multiply the whole equation by -1. And then I will have y equals -6 plus 3x. And you can label this equation 3. That is my third equation. Now let's take a look at step number 2. It says substitute the third equation into the equation you have not used and solve for the unknown. Now, I have used equation number 2, and the equation that I haven't used yet is equation number 1. What does it mean to substitute equation number 3? It means that wherever I see a y, I am going to use the expression that represents it. So let's write it together. We have -8x plus 3. And instead of that y variable, I'm going to use the expression that represents it, -6 plus 3x equals 5. Now, I want you to expand, simplify, and solve for x. So we have -8x minus 18 plus 9x equals 5. -8x plus 9x gives us x equals -18. We move it over and becomes positive. 18 plus 5 equals 23. And that is your x value. Now that we have our x value, we are ready to find the y value for the system of equations. And let's look at the next step, what it says. It says substitute the found value to find the other variable. So substitute the value into that third equation. So we have y equals -6 plus 3. And again, wherever I see x, I'm going to write the value that represents x, which was 23. So let's see what we get. -6 plus 69 y equals -63. Now you can write your therefore statement. The point of intersection is 23 and positive 63. The second example, that we have over here is x plus 2y equals 4 and x minus y equals 1. Now, as we noticed in the first example, it was easier to isolate a variable that had the coefficient 1 or negative 1. In this example, we have more opportunities, more choices to isolate one of the variables because both x's in the two equations have the coefficient 1 and the y in that second equation has the coefficient 1. So I'm going to choose actually the x in that second equation and I'm going to isolate it. So x equals y plus 1. And that becomes my third equation. And where do I use it? I use it in the equation that I have not used before, which is number 1. And wherever I see x, I'm going to write y plus 1. So y plus 1 plus 2y equals 4. And we're going to simplify and solve for y. So we have 3y equals 3, y equals 1. Now that I have the value for y, I'm going to substitute it back into my third equation. I have x equals 1 plus 1 or x equals 2. Therefore, the point of intersection of the two lines represented by the system is 2 and 1.